Hello and welcome to this month's presentation of the Dark Sky Virtual Festival. I'm Tony Pistilli, board member and Dark Sky ambassador of the Fountain Hills Dark Sky Association, whose goal it is to educate and inspire you to understand and preserve our dark skies. I'm an aerospace engineer and have been an amateur astronomer for over 50 years, following developments in space, and I'm here to present to you today the history and discoveries of the Hubble Space Telescope and its achievements in its 30-year history's research and its questionable beginnings through its most incredible findings, some of which were completely by accident, and the plans for the next space telescope, the James Webb, that is scheduled to launch on December 11th, 2021, increasing our knowledge of the universe to the next level. The JWST will advance our knowledge of the universe yet to be seen, observing some of the most distant galaxies in our universe. In 1609, Galileo Galilei heard about Dutch perspective glasses that place two lenses together in a tube to create a viewing glass with a 3x magnification, and within a day Galileo had designed his own without ever seeing it. He had made some improvements though. It could magnify objects 20 times, and presenting it to the Venetian Senate, he was hired to do research by the church. Galileo was the first to point a telescope skyward, and he was able to make out mountains and craters on the moon, as well as a ribbon of diffuse light arching across the sky, our Milky Way. He also discovered the rings of Saturn, sunspots on the sun, and 4 of Jupiter's moons that he noticed did not orbit Earth, which launched a revolution and changed our view of the universe and ended up placing Galileo under house arrest. But as telescopes got larger, so did our reach into the heavens, and so did our need to improve the technology to see beyond Earth and our own solar system. Edwin Hubble first entered the astronomy scene in the early 1900s with the likes of Albert Einstein and many of the great scientific minds of its time. Imagine a time when there was only one known galaxy in the universe, our own Milky Way. But on December 30th, 1924, American astronomer Edwin Hubble announced that he had evidence that the Milky Way galaxy was just one of many galaxies in an ever-expanding universe. For many years, astronomers had been studying many odd objects in the night sky, such as the Messier objects and the NGC Nebula, and what was believed to be clouds of gas and dust that could not be identified or distances could not be determined. But Hubble made a discovery by looking through the 100-inch telescope at Mount Wilson in Southern California. Training his gaze on the Andromeda Nebula, as it was called then, he noticed stars similar to the ones in our own galaxy, only dimmer. One of those stars was a Cepheid variable that permit astronomers to estimate distances, and Hubble deduced that the Andromeda Nebula was not a nearby cluster of stars at all, or a nebula, but entirely different galaxy, not unlike our own Milky Way. He was literally looking back in time at a sister galaxy of the Milky Way, some 2.5 million light years away. But by the 1930s, just 6 years later, most astronomers had been convinced that the Milky Way galaxy was one of many galaxies in our universe. The very notion that there were more than one galaxy in the universe was revolutionary and earned Edwin Hubble the title of the greatest astronomer since Galileo. With this information, we can see why the first ever space telescope that looks beyond our own galaxy bears his name. Ever since the time of Galileo, astronomers have ignited a firestorm of interest in the universe. Many scientific theories have blossomed from the work of Albert Einstein and Edwin Hubble that could not be proven until powerful instruments were developed to study the universe. In the following slides, we'll show that the powerful ground-based telescopes and the Hubble helped to prove many of those theories that were developed in the early 1900s. But the smog-filled skies led to a need to overcome the limitations of Earth-based telescopes, and two approaches were considered. First, large telescopes mounted on some of the highest and driest mountaintops still in use today and were put above the limitations of the atmosphere. Second, the idea came from NASA, and it was developed and use of the space shuttle that could carry a payload into orbit and allow us to see the unlimited universe without any restrictions. But the Hubble Space Telescope development was very long. Starting in 1946, Yale University astrophysicist Lyman Spitzer published a paper about the advantages of astronomy from space and introduced the idea of a large space telescope. At this time, no satellite had yet been launched or rocket been put into orbit. Many technological advantages needed to be put in place to reach this one goal of placing the first space telescope in orbit. There were many challenges of giving it a home and controlling it so that thousands of scientists and engineers and researchers could benefit from its capabilities. This would be the first time that NASA would share discoveries with the scientific community to study and evaluate the meanings of the results. Further developments in technology came quickly in the 1900s, making Hubble possible, including such things as the launch of Sputnik and the development of NASA. And in 1969, the Hubble Space Telescope project gained support. The National Academy of Sciences published a report entitled Scientific Uses of Large Space Telescopes, giving a lot of momentum to the project. And in 1974, the first working group was held for the Large Space Telescope. A meeting developed concepts for the space telescope as well as a budget and technical requirements for the spacecraft. So we were on our way to having a space telescope in orbit above Earth. Developed as a partnership between the United States Space Program and the European Space Agency, Hubble now orbits Earth some 340 miles above the surface. Its gaze outward lies beyond the distorting effects of the atmosphere, which blurs a lot of starlight and blocks some of the important wavelengths of light from reaching the ground. But how many times have this happened to your computer? Houston, we have a problem installing the new software, still can't get it to upload the photographs into the computer. Please advise. But astronomers and astronauts oftentimes need help from their ground-based scientists to complete their mission. Come on, Dad, it's simple. Taking a quick look of what's under the hood of the Hubble Space Telescope, you can see here that there's a lot of fancy equipment like advanced cameras for surveys, cosmic origin spectrograph, prime guidance sensor, a primary mirror and a secondary mirror, and solar panels, of course, to provide power, The Space Telescope imaging spectrograph gives it the ability to obtain high-resolution spectra, support systems for computers, batteries, gyroscopes, and reaction wheels, and also a wide field camera that is the main imager for the telescope. All of these things are put together and put into space. And shortly after launch in 1990, the Hubble was found to have a spherical aberration in the primary mirror that was ground in Germany years before. Although it was a very small aberration, only 1/50th the thickness of a human hair, for a telescope that was going to be used to discover phenomena that were billions of light years away, this was a devastating development for the project's future. So NASA planned and scheduled servicing mission number 1 as suggested, and in 1993 the space shuttle program was used to repair the aberration. 5 other repair missions were scheduled from 1993 through 2009, making Hubble one of the longest running space telescopes in the history of NASA. Even with its spherical aberration, Hubble was found to have a far greater resolution than ground-based telescopes. And you can see the result in this slide. The photograph on the right was taken with Hubble's spherical aberration, and you can see how much more detail there is on this photograph of this galaxy that's distant versus the ground-based telescopes on the left. Some of the other major events that were photographed by Hubble during this time: the disk of a black hole was discovered in 1992, a revelation that proved their existence and brought us closer to understanding the makeup of galaxies. Many theories were also proposed through the years that asteroids had existed and impacted planets, including Earth, and Hubble captured one such occurrence when it struck Jupiter in 1994 in several pieces and were recorded with the Hubble Space Telescope after its corrective lenses had been placed in. Starbursts were imaged in other photographs, as well as being able to study and understand the origins of our solar system and sun. Even in the early days of astronomy, astronomers were studying moving objects in space to determine what they were and whether or not they had an impact on Earth. Asteroids are nature's way of asking this question: how's your space program coming, Earthling? Well into its third operational decade, the Hubble Space Telescope is still very productive. The orbiting space telescope has taken over 1 million observations already and provided data that astronomers have been able to use to write 16,000 peer-reviewed scientific publications, everything from investigating planet formation to the existence of gigantic black holes. Hubble's theories and memorable photographs have also reinvigorated the public's interest in astronomy. The Hubble Space Telescope looks deeper into space the farther back it looks in time. Distances are so fast that they are measured not in miles, but in light years. So many objects that we are looking at, the light left those objects millions of years ago. These towering infernos of cosmic dust and gas sit at the heart of M16, called the Eagle Nebula, and are named the Pillars of Creation. And they're featured in this stunning Hubble image as part of an active star-moving region within the nebula and hide newborn stars in their columns. This is Hubble's most detailed image of the Eagle Nebula, showing the blue colors representing oxygen, red is sulfur, and green represents both nitrogen and hydrogen, indicating how well the HST can identify objects visually and chemically, giving scientists a basis for how these stars are formed and how nebula are developed into stars in space. Stretching roughly 5 light years in height, the pillars of creation are a fascinating but relatively small feature in the entire Eagle Nebula, which spans 55 by 70 light years. This photograph is called the Extreme Deep Field image that was taken by Hubble as an experiment. It was an area in space that was assumed to be void of any activity. It is an area no bigger than looking through a soda straw. Hubble's aperture was open for a total of 2 million seconds over several weeks, and astronomers were astounded to find a minimum of 5,500 galaxies. This has completely changed the estimate of how many galaxies there are in our universe. In this particular slide, we're looking at worlds beyond our sun. And the immediate reaction that I have is, "Hi, neighbor." At the time of Hubble's launch in 1990, astronomers had not found any planets outside our solar system. Scientists have now confirmed the existence of more than 5,000 extrasolar planets, most of them discovered by NASA's Kepler Space Laboratory and also by ground-based telescopes. Hubble, however, has made some unique contributions to the planet hunt. This star system is located only 25 light years away and has such a planet orbiting at approximately 800 billion miles away from the Sun. The Hubble space observations demonstrate that basic organic components for life can be detected and measured on planets orbiting other stars. Astronomers used Hubble to make the first measurements of the atmospheric composition of extrasolar planets. And Hubble has spent a lot of time discovering galaxies around the universe. This photograph of NGC 2903 is located about 30 million light years away in the constellation of Leo the Lion, and was studied as part of Hubble's survey of the central regions of roughly 145 nearby disk galaxies. Containing an incredible 500,000 stars, this 8 billion-year-old star cluster is one of the largest and brightest globular clusters ever discovered. M3 is commonly acknowledged to be one of the most beautiful. However, what makes M3 extra special is its unusually large population of variable stars. These are stars that fluctuating in brightness over time, and new variable stars are continuing to be discovered in this spectacular nest in the city. But so far, we know of 274, the largest number found in any globular cluster. And we know that variable stars are used by astronomers to determine distances of objects in our with 5 times the mirror diameter, or 40% larger area, and the ability to see the far reaches of the universe that we have not yet been able to explore with Hubble, the James Webb Space Telescope will be able to see the equivalent of a bumblebee's visible light at the distance of the moon, and also detect its body heat as well. It will be placed some 1.5 million miles from Earth to avoid the interfering heat and ultraviolet light and be insulated from the sun and maintained at a minus 388 degrees Fahrenheit. And it will be able to detect the faintest of galaxies and nebula in deep space that Hubble has been able to record. Expected to be launched in December of 2021, it will be able to see even more detail and further into the past than Hubble has been able to see. Move over, Hubble. Here comes the James Webb. From the Dark Sky Association and from me, Tony Pistilli, thank you for allowing me to enter your offices today and attending this month's online presentation of the virtual Dark Sky Association Festival, and for your interest in dark sky and the soon-to-be funded and built International Dark Sky Discovery Center. We wish you all the best for this holiday season and great viewing of the night sky in Fountain Hills. You'll have to come out and see us at the next star show. Be sure to join us for the upcoming Dark Sky Festival next spring. Watch for updates on timing and please consider volunteering to create this great educational event right here at the Community Center.